So let's say you want to measure the length of the rational numbers. Well, first of all, we should probably talk about what that actually means. So in math, when you have some sort of idea or some vague concept, it's usually a good idea to make it rigorous and talk about a set of properties that things should have that you can use as a list of axioms to build upon. So for the length, we could say the length of an interval a comma b is b minus a for b greater than or equal to a. We can say that the length of the union of two sets is less than or equal to the sum of the lengths of the individual sets. And the reason why it's less than or equal to instead of equal to is a and b could overlap a little bit and then you'd be over counting. So there's going to be equality if a and b are disjoint. Okay, so and this should also apply for infinite unions and sums. That just seems pretty obvious. The length of a set should always be non-negative. And finally, we should have the length of a subset less than or equal to the length of the total set. So that's property number 4. So these 4 properties are like common sense things that any sort of notion of length that's reasonable should have. So with these properties, we can actually show that the length of Q, the set of all rational numbers, has to be 0. Here's the proof. So basically, we have to start with these common axioms, and then from there, we have to logically deduce that the length of the rational numbers has to be 0. So the first step is to list out all the rational numbers in a sequence, Q1, Q2, Q3, on and on and on. So for example, you can look at this. This is one of those listings. And then we're going to come up with a sequence of sets, O, N, that basically covers each rational number with a little interval. So here we have an interval that's centered at Q with length 1 over, or epsilon over 2 to the n, where epsilon is just some positive number. So at each rational number, we'll have a little interval, and each of these intervals will get smaller and smaller as you go further along in the list. Now, if you take the union of all the sequence of sets, then it'll cover every single rational number because every single rational number appears on this list. So the union of all this is Q is a subset of the union. So therefore, we can say that the length of Q is less than or equal to the length of the union, which is less than or equal to the sum of the lengths of each individual interval, which is equal to the sum of epsilon over 2 to the n, which is epsilon, just by the geometric series formula. Then, since our epsilon greater than 0 was arbitrary at first, that means we've shown that the length of Q, whatever that must be, has to be less than or equal to every single positive number, basically. So the only number that's less than or equal, the only non-negative number that's less than or equal to all the positive numbers is 0. So the length of Q is 0. So this is an example of how math is usually done. You have a set of common assumptions, and from there you deduce things. And another thing I like about this proof is it shows the necessity of the real numbers, because if rational numbers were the only thing that we had, then the length of all of them would be 0. But we know for something like an interval, a comma b, the length is obviously not 0. So that means that there has to be more numbers inside that interval than just the rational numbers. There are irrational numbers as well. Okay, that's it for this video. Bye.